So students, this is the first question of ISC Board 2025. Here we have, if A is a matrix like this, which is a 2 by 2 matrix where the second element of the first row is A only, then we have to tell A raised to the power 16 is what? So in such a scenario, what we have to do, we have to first find A square so that we will come to know about the pattern of this expansion. So let's first expand this A square, 0 A 0 0, and we have to multiply this with again A. So here first row first column, that is 0, then again 0. Now first row second column will give you 0 into A is 0, A into 0 is 0. Now this row second row, 0 into 0, 0 into 0. Here again this row with this column, so A into 0 again 0. So what we are getting here is a null matrix. Obviously if we further find the higher powers of A here, that means A cube, A raised to the power 4, etc., we are going to get a null matrix only. So you need not to waste your time here in such a questions. Simply you have to say that null matrix, that is the option B, is your correct answer. So I hope your concept is clear for such questions. Now let's move towards our second question. So this is the second part of question number 1. Here it is asking which of the following is a homogeneous differential equation. For homogeneous differential equation, we should have dy by dx, f of xy, g of xy should be equal to f of lambda x, lambda y upon g of lambda x, lambda y, and this is again will give you this part only, that is f of x y upon g of x y. That means if we are going to multiply x with lambda and y with lambda, after simplification we should get again the same function in x and y, and lambda is going to eliminate here. So let's try out our first option, what it says. So here if we separate the dy by dx part, we can write it this way: dy by dx equals to 4x square plus 6y plus 5 upon 3y square plus 2x plus 4. So in such a scenario, in such a questions, you need not to simplify these questions here by putting lambda and wasting your time. Simply we can see, if we multiply x square with lambda here, y with lambda y, then we won't be able to take out the common terms lambda here, due to which it is not going to cancel lambda here, since we can say that this is not the correct option here. So now what we can do, we can test the second part here, and we can easily see that the numerator part here, dy by dx equals to what? xy upon x cube plus y cube. Here degrees are different here, so here also we won't be able to cancel out our lambda term. Similar way, now let's check out the part C here, which states x cube plus 2y square 2xy dy. Again, if we convert it into dy by dx, that means if we are going to separate dy by dx here, what we'll get here? dy by dx equals to x cube plus 2y square upon 2xy. So here again the degree of x is higher, so if we multiply it with lambda here, lambda cube x cube, and here we are getting lambda square, due to which we are not going to eliminate, we won't be able to eliminate lambda here, due to which this is also not a case of homogeneous equation. Now let's check this one. Here we will get dy by dx equals to, this part will go here, Now dy by dx will be y square upon x square minus xy and plus y square. Here we can easily see that here we are getting this way lambda square y square, and here we are getting lambda square x square minus lambda square xy plus lambda square y square. See, here we can easily take common lambda square from the numerator as well as the denominator, due to which it is going to get cancelled. Lambda square upon lambda square will get cancelled and we will get the function in x and y. Therefore we can say that option number D is the correct answer here. Now let's move towards the third part of first question. So this is the third part of the first question. Here it states, consider the function fx as it states in this particular graph. So statement 1 is the function fx is increasing in half comma 2. Here we can easily see that the function increases from half to 1. After that it is not increasing. So this is the point of inflection, you can say. Similar way, statement 2, the function fx is strictly increasing in half. So we can easily see that it is strictly increasing in half to 1. So this is the correct statement here. And the statement, this one, that is the first one, is the wrong statement and statement 2 is the correct statement. So statement 2 is correct and statement 1 is false here. So option B is the correct one. Now let's move towards the fourth part of the first question. So this is the fourth part of the first question. Here we have the integral question where we have to evaluate this integral. So here you need not to get confused that the degree of this is higher and how we are going to elaborate here or how we are going to evaluate this. So here we can easily see that you can write it the numerator like this way by using a square minus b square here. Very simple question. So you can just cancel it out. Now you will get x square plus minus 1 here. Now integrate this, simple. So what you will get here, x cube upon 3 minus x. Now put the limits here. Very simple question, right? Within 1 minute you can easily solve such questions. Now what we can do, we can simply put the upper limit, lower limit is 0, so we need to calculate here. So 1 by 3 minus 1, which will give you 1 minus 3 is minus 2 upon 3. So minus 2 upon 3 is there in the option. Yes, here C, option number C is the correct one here, right students? So that was a very simple question. You have to factorize such questions when higher degrees are given. So it was given just to confuse the students. Now let's move towards the fifth part of the first question. Here we have the question from relation function. It states that if set A has m elements and set B has n elements and n is less than m, then the number of 1 function from A to B is 0. So let's first understand our assertion here. Before that, we should understand what is a 1 function here. So 1 function is basically, we have a map here. This is the domain and this is the codomain. So 1 only happens when each element in the domain have a separate map or separate image in the codomain here. So which implies that the number of elements in the domain should be equal to, let us say it has m elements and it has n elements, then m should be less than or equal to n here. Then only injectivity may happen. That means 1 function may happen. Otherwise it will not happen here. And if we check the assertion, if set A has m elements and B has n elements and it states the opposite what we have stated here. So m should be less than or equal to n, only then the 1 or injectivity may happen. In this case we can say the assertion is true as it states that the number of 1 function from A to B is 0. So there will be no 1 function here. Now let's check the reason here. It states that a function a to b is defined only, a function a to b is defined only if all elements in set A have an image in set B. So basically it is generalization of our definition of the function, we can say. This is the definition of a function which states that AB is defined only if all elements in set A have an image in set B, and we can say the reason is correct, but it does not explain our assertion, which is our 1 function. As we can see that assertion is explaining about the 1 function, however the reason is for only about the function, as 1 only happens when all the elements in set A will have an image in set B, and it is not explained here. However, the reason is correct, but it is not the correct explanation or correct reason of our assertion. So we can say that both assertion and reason are true, but reason is not the correct explanation for our assertion. So hence option number B is correct here. So I hope the concept of 1 function is clear now. Now let's move towards our 10th part of first question. So here we have the question from probability distribution. Here it states that let x be a discrete random variable. The probability distribution of x is given below, and we have to find E of x here. We know that Ex equals to sigma xi into P of xi. So what we have to do, basically we have to multiply these terms and sum them. Very simple. So 30, basically we have to do 30 into 1 by 5 plus 10 into 3 by 10 minus 10 is there, minus 10 into half. So we have to simply do the multiplication and add them. So here we get 6, here we get 3, and here we get 5. So basically 6 plus 3 minus 5, 9 minus 5 is 4. So very simple. It was a very simple question. So our option B is the correct option here. Now let's move towards the 11th part of the first question. So here we have the first statement, which states that if A is an invertible matrix, then A square whole inverse is equal to A inverse whole square. Now let's first understand the property of inverse. Here we have A, as we know that AP whole inverse is equal to B inverse into A inverse. Also we have A square is equal to A into A matrix. By using these two properties, we can verify our first statement. Simply. How? Let's first check the LHS part. A square whole inverse can be written as A into A whole inverse, which can be further written as A inverse into A inverse or A inverse whole square. Very simple. Here we got A inverse whole square, which is equal to RHS. Hence we can say that our statement 1 is the correct statement. Now let's understand the statement number 2. If A is an invertible matrix, then A inverse whole determinant is equal to inverse of A determinant. Now here, using the property of invertible matrix, we know that A inverse whole determinant equals to 1 upon determinant of A. Similarly, the RHS part, which is determinant of A inverse equals to 1 upon determinant of A. Hence we can say that here also our LHS equals to RHS. Therefore our statement 2 is also correct here. So we can say that both the statements are true here. So option C is the correct answer. Now let's move towards the part 12th or question number 1 here. The question is, write the smallest equivalence relation from the set A to A where A is equal to 1 to 3. As we know that the equivalence relation happen when it follows reflexivity, symmetric and transitive. every element should be related to itself. Here A relate to A, then it is reflexive. Symmetry, if A relate to B, then it should imply B relate to A here. For transitive, if an element A relate to B and B relate to C, so this implies A should relate to C. So for the smallest equivalence relation, all the elements should satisfy these three conditions. So here we can easily form a set like this. So the smallest possible set is 1 1, 2 2 and 3 3 here. So this is the smallest possible set which is of equivalence relation here. Now how this set satisfy these three conditions? See, A is related to A, that is, if we check each set here, then we'll see that 1 is related to 1, so it satisfies this. 2 is related to 2, 3 is related to 3, then all the set satisfy this reflexivity. Now if we talk about the symmetry, then 1 is related to 1, that is A related to B. Similarly 1 is related to 1 itself. Similarly we can see these two elements here. Now if we check about the transitivity, here A is related to B, that means 1 is related to 1 in the first set. We can check 1 is related to 1, here B related to C, so B is also 1 and C is also 1. So similarly A is related to C, so 1 is related to 1 itself. Similarly in this case and this case as well. Therefore we can say this is the smallest equivalence relation set from A to A, where A is 1 2 3. Now let's move towards the part 13th of question number 1. This is the part 13 of question number 1, where it is the question of matrices and the concept is skew symmetric matrix. So as we know, for skew symmetric, A transpose should be minus A. Here we have to check the condition for skew symmetric matrix. First condition is if the diagonal elements are 0, so the principal diagonal elements are all 0. Also the second condition, we can verify that Aij equals to minus of Aj. So here we can see that the position of minus 2 is what? Position of minus 2 is first row and third column. So first row and third column is equal to minus 2 here, and the position of x is third row and first column is x here. So as per this condition, what we should have, basically we should have x equals to minus of minus 2, which is plus 2. So x equals to 2 here. If x equals to 2, then the given matrix is a skew symmetric matrix. So that was a shortcut for this particular question. I hope you understand and enjoy this concept. Now let's move forward toward the part 14 of question number 1st. So here we have the part 14 of question number 1st. 3 critics review a book. Odds in favor of the book are 5:2, 4:3 and 3:4 respectively for the 3 critics. Find the probability that all critics are in favor of the book. So in such a scenario where we need to find the probability in favor of the book, then what we have to do? See, if we have the odds in favor of, let us say this is A ratio B, then probability in favor of will be written as A upon A plus B. Okay, so simply we need to find this probability. So for the first critic, odds in favor of the book for the critic 1, so probability of the critic 1 is equal to 5 upon 5 plus 2 is 7. Similarly probability for critic number 2 is 4 upon 7, and probability for the critic number 3 is 3 upon 7 only. So what we have to find the probability that all the critics are in favor of. So simply what we have to do is multiply these three probabilities, PC1 into PC2 into PC3. So here we can simply find the product of these three. So 5 by 7 into 4 by 7 into 3 by 7. So here we will get 5 4 20, 23 60, 7 7 49, 49 into 7, 343. So we will get 343. So our final answer will be 60 upon 343. I hope the concept is clear now. Now let's move towards the last part of this question, that is part 15. So this is the 15th part of the first question, which is the last question, which is of integration. Here we can simply 2x plus 7, we can simply substitute 2x plus 7 is equal to t. So this implies 2 is equal to dt by dx. So our integral will become 5 by 2 into 1 by root t. Simply we can write it this way. Now we can write it this way further, t raised to the power minus half into dt. Now we have a very simple integral here. So here we have t raised to the power minus half. We can write it this way, very simple, t minus half plus 1 upon minus half plus 1 plus c. So t raised to the power, this is nothing but what? Root t. So root t upon 1 by 2, or we can simply cancel out this. So 5 root t plus c is our answer. You can simply substitute the value of t. T is what? 2x plus 7. So our final answer will be 5 into root over 2x plus 7 plus c. So I hope all the questions are clear now of first section. We are going to meet in our next video, where we are going to discuss about all the questions of section A. Thanks for watching the video. If you like the video, you can subscribe and share this video so that other students will get benefited. Thanks a lot.